543.42 meters. So that's right at two decimal places. Okay, so we've just determined the length of the power line. We can also determine the angle of elevation. Feeder. So using simple trigonometry, we can determine the angle of elevation. So tan theta is equal to the opposite. So in this case, the opposite is 398 meters. 398 meters. The adjacent is 370 meters. Therefore, the angle of elevation is simply inverse tan 398 on 370. So theta elevation is equal to angle of 47 degrees 47.08 degrees, or more accurately, the angle of elevation expressed in degrees, minutes, seconds is equal to (47 degrees 53 minutes and 9.89 seconds. Slight error with the calculator. In degrees, minutes, seconds, it is actually equal to 47 degrees 5 minutes 16.74 seconds. Okay, so let's recap on how we went about determining the angle of elevation and the length of the power line. So let's refer back to the 2D contour map. So we had a house located at an elevation level of 800 meters, so 800 meters above sea level. We had the power pole located 400 meters above sea level, and from the home stretches a power line all the way down to 400 meters. And we want to determine the length of that power line. So what we did is we grabbed a ruler and measured the distance, the horizontal distance from the house to P. Okay, and just before we determined the horizontal distance, we jotted down a few facts. The height of the home is 4 meters, located at an altitude 800 meters. The height of the power pole is 6 meters, located at an altitude of 400 meters. So in order to determine the horizontal distance from H to P, we measured with our ruler a distance of 37 millimeters. And we need to get we said, how do we determine the real life length? So we know the scale of the map is 1 to 10,000. So multiplying 37 millimeters by 10,000 gives us 370,000 millimeters. Divided by 1,000 enables us to convert it to meters. So we're left with 370 meters. So we've just established that the horizontal distance from point P to H is 370 meters. Now we know that the power pole is located at an elevation 400 meters, and we know the pole itself is 6 meters long. So the point we're interested in is located right here. The other point is located at 104 meters above sea level. The reason being is the house is situated at the peak, which is 800 meters above sea level, and the house is 4 meters high, therefore the very top of the house is 804, and that's where the power line is connected. So from the top of the house down to the power pole, so the top of the house down to the power pole is the length we are trying to calculate. We've got now we've got all the information we can do the calculation. So 804 minus 406 gives us the height, which is 398 meters. We know the horizontal distance, 370 meters. We can calculate using Pythagoras' theorem the length of the power line. So substituting the necessary information into the equation, we obtain the power line length to be 543.42 meters. So that's to 2 decimal places. Next, we can calculate the angle of elevation by using basic trig ratio. In this case, the particular trig ratio we're interested in is tan. The reason being is the angle here, this side is opposite, 398, and this side, the two sides we're interested in, one is the opposite, the other one is the adjacent, therefore that gives rise to the tan trig ratio. So using the tan formula, tan theta is equal to opposite on adjacent. Substituting the necessary information like we have here. Remember, we're trying to calculate theta, so we have to take tan to the other side. It becomes inverse tan, and we end up with 47.08 degrees, or more accurately, expressing in degrees in seconds, we have 47 degrees, 5 minutes and 16.74 seconds.